Hello, guys. Can you hear me?
Yes, I can hear you.
How are you guys doing?
I'm good. How are you?
Fine, thank you. Yeah, I couldn't make it to the campus today, and I posted a message about our meeting on remotely in Canvas. So I have three people yet. I think we can start with since we are three now. Others can join us later. Mm. So on Monday, I introduced you to inventory. We did more work on inventory management on Monday. So today we will continue. We'll start from inventory models. But before I discuss that, I want to take you to the classroom again to remind you of this week's assignments. Let me see if I can pull it from here. For those of you who weren't here yesterday, I mean, on Monday. This is where we are. And as you can see from my announcement here, this week is assignment is classwork 8, which I will put, may I make it available tonight or tomorrow night. Then projects. I recommend you start doing the project so that you can finish by December 1, which is the due date for it. And you can find it from here. I'm going to models. Scroll all the way down to the project. This is the first one. The second one is just the second project will be the final exam. It will be the presentation of the work you did on this one using a PowerPoint. So this is the project right here. So after today, after this class, you'll be able to start the project. Okay. So after this, you can start the project. Like I said, the final exam will be the project presentation. You write a narrated PowerPoint where you present the work you did on the project to us. That's what I'm going to use for your final. Okay? As a final assignment. All right. Let us begin. Any question before I start? Any question, guys? Hello, guys. Any question for me? So no question there. Good. Good. Let's start with inventory models. Excuse me. Now, the inventory, before we do that, there's some concept we need to know about inventory models, or that we need to know before we jump into the discussion of inventory models. Now, those terms are dependent versus independent demand. Now, inventory control models, usually they assume that demand for an item is either independent or dependent on the demand for other items. So the demand for one item is either dependent or independent of the demand for another item. For example, that I have here, the refrigerator. The demand for the refrigerator is independent of demand for TV. But the demand for both the refrigerator and the TV are dependent on the demand for electricity. Because if you don't have electricity, you can't have watch TV or use refrigerator. So that's kind of thing. Now, another thing we need to look into is what they call the holding costs, ordering costs, and setup costs. Now, holding cost simply means the cost associated with holding or carrying inventory over time. And those costs comes in the form of things like obsolescence or costs that are related to storage. Storage costs such as insurance, extra staffing, to look after the inventory that is being stored, and the interest payments. So these are what you call the holding costs. Next is the ordering cost, which includes cost of supplies, forms, order processing, purchasing, clerical support, and so on. Now, the other one is the one we call the setup cost. And the setup cost is a cost that is associated with preparing a machine or a process for manufacturing an order. So this cost, I mean, the setup cost includes time and labor to clean and change tools and holders. So operation managers are, some of them can figure out a way to lower this cost by reducing things like lowering the ordering cost by reducing things like the setup costs and by using efficient procedure as things like the electronic ordering and payment system. Okay. Now, having given you this background, I think we can now jump into the inventory models now. Inventory models. Okay. Now, let us introduce them. We have when we discuss inventory models, we say that there are three inventory models that address two important questions with respect to inventory management. Now, the first question is when to order and how to order. So now below are three independent demand models. One is the basic economic order quantity, EOQ model. This is the one we're doing today, and this is the one that your project is based on. Then production order quantity model, and then quantity discount model. Let's start with the basic economic order quantity model. Now, according to the basic economic order quantity model, or what I call the EOQ, or just kiosk star, so this model refers to the number of units that a company should add to inventory with each order to minimize the total cost of the inventory. So it means that the number of units that a company should add to the inventory with each order so as to minimize the total cost of the inventory. Such as of course, when I say total cost, the costs that factor into the total cost include holding costs, the other costs, and the shortage costs. So usually, the EOQ, which is the economic order quantity, or the kiosk star, is one of the most commonly used inventory model or techniques. So and it has some assumptions too. The first assumption, well, I think the best way to put it is that it is based on several assumptions. First one is that it assumes that the demand for an item is known. Which means that the demand for the item is known, is reasonably constant, and is independent of decision of other items. It also makes some assumption about the lead time. That is the time between it makes assumption about the lead time, which is the time between the placement and the receipt of the order. So according to this model, the lead time is known and consistent. Now, the third assumption is that receipt of inventory is instantaneous and complete, which means that the inventory from an order arrive in one batch at one time. That's another assumption. Now, the fourth assumption of the EOQ model is that the quantity of discount are not possible. I mean, quantity discount are not possible. Then the fifth assumption is that the only variable costs are the cost of setting up and placing an order, which is the cost we call the setup cost or ordering cost, and the cost of holding or storing inventory over time, which is the holding or carrying cost. So these costs we discussed them already. Now, the last assumption here is stockout or shortages can be completely avoided if orders are placed at the right time. So that's another last assumption of the economic order quantity model. So now, we are now ready to look at minimizing costs. So, of course, these operation managers are always, uh, I would say that they are always uh, trying to figure out a way to minimize costs. So their goal in that line, along that line, is to minimize total costs. So with the assumption just given that in the previous slide, a significant amount of costs of our setup, which is the ordering costs, and holding costs, which is the carrying costs. So all other costs, including the cost for the inventory itself, are constant. So that now, so that means that if they can minimize the sum of the setup and holding costs, in general, if operation managers can minimize the sum of the setup and holding costs, they can also be able to minimize the total cost. And I'm going to use a figure to analyze this. So the figure I'm about to show you, in that figure, we will graph the total cost as a function of the order quantity. You can see it right here. Okay? Total cost as a function of order quantity. You can see the minimum total cost, optimal order quantity. And this is the cost. The vertical axis is the cost, and the horizontal axis is the order quantity in units. So this line represents the ordering cost curve. This one represents the carrying cost curve. And this one represents the cost for total costs of carrying and ordering costs. So you can see that the optimal size, the optimal order size, Q star, will be the quantity that minimizes the total cost. So so based on what I will show you in a minute, you will discover, you see from the graph that as the order size increases, the total number of orders placed per year will decrease. Which means that the quantity ordered, as the quantity order increases, the annual setup cost will decrease. So you can see from here, this is the quantity ordered has increased. The ordering cost, as you can see, it decreases. However, the carrying cost will be increased. As the quantity ordered increases, the carrying cost will go up. Okay? But as it increases, you see that the ordering cost show that the ordering cost will decrease. Okay. Now the optimal order size, Q star, will be the quantity that minimizes the total cost. And this you can see the optimal order size here. But optimal order size is Q star, and that is because that minimizes this is the cost where it touches the curve for total cost of carrying and ordering. This is where this is the minimum total cost. And that is where the optimal order quantity lies. Okay. Now, but as the order quantity increases, also the holding cost, obviously more quantity ordered, then you have to store them if you don't sell them off immediately. So that means that the holding cost will increase due to the larger average inventory that are being maintained. Okay, you can see that here. See the holding cost or carrying cost. See, increases as the order quantity increases. Okay. Now, having given you this background, we are now ready to do an example that will help you in doing the project. Okay. Before you start the project, you can watch this video. You can even watch it as you do the project. Look at this question here. Before I do the question, I want to give you the formula. The optimal order quantity. So with the economic order quantity model, the optimal order quantity, like I showed you on the graph, will occur at the point where the total setup cost is equal to the total holding cost. So using the following variables, we can now determine the formula, determine the setup and holding costs, and solve for the number of units per order. The optimal number of units per order. So let's assume that Q represents the number of units per order. Q star is the optimal number of units per order, or what we call the economic order quantity. D is the annual demand in units for the inventory item. S is the setup or ordering costs for each item. And then H is the holding and carrying cost. Once you have all this, we can now use the equation, EOQ equation or the Q star equation to calculate the economic order quantity. I mean, Q star equals square root of 2 times D times S over H, where, of course, D is the annual demand in the unit for the inventory item. 2 is a part of the formula. S is the setup or ordering cost. H is the holding or carrying cost. With this, we can solve one question. Give me 1 minute. Let me get some information from my book. I think I have something here. Yeah. What is it? What is it? What is it? What is it? Okay. Okay. All right. Let's see. You probably see it. So let us solve this question as an example. We have which it says Sharp Incorporated is a company that markets painless hypodermic needles to hospitals. And it would like to reduce its inventory cost by determining the optimal order number of hypodermic needles to obtain per order. The annual demand is 1,000 units. The setup or ordering cost is $10 per order, and the holding cost per unit is 50 cents. Using this information, calculate the company's optimal order quantity, optimal number of units per order. Assume that we have a 250 day working year. Calculate the number of orders and the expected time between orders. T. Part C says determine the company's total annual inventory cost. So let's do it. I put all this information in Excel. You can see it right here. Let me make it a little bit big. I'm gonna right here for Sharp Incorporated. Sharp Incorporated, right? Sharp Incorporated. So I'm going to make it whatever I can make it to be size 16. Okay, good, that's better. So again, the information we are given, I'm gonna review it again. You can see that they say that the company markets painless hypodermic needles to hospitals, and it would like to reduce the inventory costs by determining the optimal number of hypodermic needles to obtain per order. So the annual demand is 1,000 units. Setup or ordering cost is $10 per order, and the holding cost per unit is 50 cents. So using these figures, calculate the company's optimal number of units per order. So I put all these numbers in Excel. You can see them right here. Okay. Now, the optimal, you can see the formula right here, or the economic order quantity. At the same time, I also did some of the calculations here in the PowerPoint too. See? So I put all those things in. So let's go back to Excel and finish up the calculations, okay? So part A says the optimal quantity. So we have EOQ right here. So the formula is right here. 2 times square root of 2 times DS over H. So I have the 2 right here. 2 is part of the formula, so I put the 2 right there. Demand is 1,000. Setup cost, ordering cost per unit. I think I'm gonna make it like this. It's $10. Okay. This is money. I'll change this to let me leave that. Of course, they're money for $10. Now, and then ultimate cost, economic order quantity, or the optimal number of units will be square root of 2 times DS over H. So how do you put square roots? in Excel. I'm going to show you in a minute. I'll put up to say this is square root of 2 times ds. So this is what I did on in PowerPoint. Now let's do it in Excel now. Okay. So square root is going to be put equal sign, then SQRT, it will pop out here. Double click. It said 2 times D times X. I'm going to put parentheses. 2 is right here. Click on it. Times is this asterisk symbol. Now D is demand right here. Times, again, another asterisk symbol is this times. Instead, we use asterisk symbol for times. S, and S is right here, $10. Close it. And it's said to divide it by H. Divided by H. Our H is 0.05. Then you close the parenthesis. Now, if we press the enter key to give you the answer, it's 200 units. 200 units, okay? Which is the same unit amount we got in our PowerPoint presentation, 200 units. Next question. Before I do that, any question on what I just did? Hello, scholars. Any question on what I just did?
Nah.
Good, good. Now it says here, part 2 says that, okay, assume that we are 250 day working year, calculate the number of orders and the expected time between the orders. Okay. So taking you there, number of orders, can see the formula right here. So let me remove this one. Put this one here. Okay. This one is demand divided by order quantity. So equals demand is 1,000 divided by order quantity, which is the 200. See, 200 is the order quantity, so 200. 5. So you can see right here, 5. So I'm gonna use a different color for that. Okay. Now we answer that. Then, but there's another question they ask us wanted to find. It says the order quantity and the expected time between the orders. Okay. Let's do that. Expected time between the orders. So I'm gonna remove this one. Expected time between the orders is formula is 3. Number of working days per year divided by expected number of orders. Okay. Now, from the question, they say that number of working days per year is 250 working days per year. By the way, the one we just did is you can see right here, 5 orders. Now, anyway, you say that there are 250 working days per year. So the expected number of orders. So let's see. You have it here. 250. See, number of working days in a year is 250. So that expected. Should I say this? So the expected time between orders will be number of working days in a year, which is 250. Equal sign. Then remember, before you do any calculation, you press equal sign. Click divided by number of orders, which is 5. Okay, that gives us 50. See, so you can see that right there. I even did it here too. You can see exactly here. So you can watch both of them as you do it. 50 days between orders. Okay, and then the other one now becomes sorry, my mistake. The question now becomes determine the company's total annual inventory cost. Okay. The total annual inventory cost for this company, we can calculate that, okay, with this formula here. Make it a little bit bigger. See, total annual inventory cost. So I'm going to, right here, formula is the D over Q times S plus Q over 2 times H. Equal, to make it simplify, put them in parentheses, okay? You have D over Q. D is right here. Well, this is for demand over Q quantity. Okay. close parenthesis, times, which is use the asterisk symbol for times S. Now S is the setup cost of $10. Then plus, okay, I'm gonna make it twice again. Q over 2, and our Q is over 2. This is 2 right there. Close this. Times H. Now H is holding cost. Close it. Okay. Then once you press the enter key, to give you the answer right away. $100. This is per unit. Okay. And you see we have the same thing here. Okay. You can see right here, $100. So that's what I wanted to show you today. Any question before we round up, guys? Hello?
No questions.
So when we start doing the project, watch this particular video. I'm gonna update the spreadsheet as well, so that you can see those formulas. Those formulas are here in the PowerPoint anyway. Okay. So let me check your names if you have no questions. Antoine, I got you here. Oh, before we leave, on Friday, we normally have a class on Friday remotely. But this Friday, I won't be available. I'm going to see my doctor again. So just continue the project. And I will see you guys on Monday, okay?
Yes, sir.
Yeah. Please don't log out. Don't log out, please. Don't log out. Let me check your names. P. Monroe. Monroe is right here. Kathleen Green. Ayeni. Harold. Who else? Who else? Somebody left. 1, 2, 3, 4, 5. Okay, who am I missing? Somebody else. Okay. All right, guys. I see you Monday then. Enjoy your weekend, yeah?
You too.
All right, thanks. You too.
You
Bye-bye.
too.
Bye.